Virtually everything in our world emits infrared radiation. This radiation is invisible to us, but we can feel it as heat. We also cannot see it with a typical digital camera. When using electricity, we know that powering motors and other components will create heat. Many times electrical malfunctions will create excessive heat before failure. Wires can overheat due to heavy use. Over time, wire connections can come loose, arc, and overheat. Transformers produce heat. Contacts of electric push buttons can arc and overheat. Motors will overheat if they're overloaded or the bearings tighten up from wear. If we can catch these problems early, we can mitigate the damage. By using a camera that photographs infrared spectrum, a thermal imaging camera or an infrared camera can show us and measure the heat given off by certain surfaces. We can use infrared photography to give us a virtual view of the surface's temperature and help troubleshoot potential problem areas. In this demonstration and accompanying lab, we will use infrared cameras from Fluor. The next video from Fluor introduces the E6 infrared camera.
Hi, I'm Joe here with our impressive new FLIR E6 infrared camera. This is really a powerful thermal imager considering how affordable it is. It's got 160 by 120 pixel thermal resolution, twice the number of pixels as its little brother, the E5. Now, not only do more pixels produce greater image detail, they help you detect and measure heat issues much better on smaller components and targets farther away. Plus, if you're a home energy rater or contractor, the E6 meets the ResNet standard. The E6 also features a more sensitive detector to help show you subtler thermal patterns. It's got a bright 3-inch LCD that makes it easy to see the heat, and an interface that's even easier to use. Quickly thumb through settings and parameters. Pick the best color palette. Review stored images. And add temperature measurement tools like this area box with an auto cold or hotspot to help quickly hunt down minimum and maximum temperatures. Or you can use the center spot measurement to accurately measure directly in the center of your screen. Plus, the E6 gives you an isotherm mode that instantly alerts you to temperatures above or below a set threshold. Choose thermal only mode, the visible image, picture-in-picture, or MSX that enhances the thermal image with the visible details you need. Like all E-Series models, the E6 comes with our FLIR Tools reporting software that you can use on your PC or your Mac, and our exclusive FLIR 2510 warranty that kicks in as soon as you register your camera.
Let's look at sample images from around our building that demonstrate thermography. We're showing the electrical equipment with covers closed on purpose. This gives us an indication of hotspots and points for specific areas that we will investigate further. Let's take a few minutes to preview some sample images that were taken, give us an idea of the difference between an infrared image and a regular picture. This shot is taken of a transformer coming into the building. We see from the thermal image that the temperature is elevated from the surrounding area, and we would expect that. The byproduct, if you want to call it, of a transformer is it gives off heat as part of its function. These shots are taken behind the transformer where the cooling fins are located, and we can see the difference in temperatures from the top to the bottom as we would expect. One here is the water cooling system going into the building, and some interesting takes on the temperature gradients in the plumbing. Now, looking inside the building at the distribution center coming in, we find that the temperature is pretty close to ambient, so we don't really see any hot spots in this photo. However, as we back away and take a shot of the right-hand side of the distribution center, we see a hot spot shown up here in the upper right corner next to the breaker box. Moving in closer, honing in on that, we notice that it is, from the picture, we can see that it is a control relay inside a box. But here we see the temperatures of it. Zoom in on the hot spot, I'll call it. We can see that it is running around 87 degrees when the rest of the area is 70. So if we're troubleshooting, it's something to think about. Maybe if something were, quote, burning up, it would be warmer than that. But as we saw from the previous image, there is one item that is an elevated temperature on the wall. These images show a circuit breaker box and give us a good idea of some things that we could look at. We see that the temperature in the upper left-hand corner of the circuit breaker box is warmer than the rest of the box. However, when we look a little bit closer at the temperature gradients, we see that the high in this image is only 76 degrees and the low is 69 degrees. So we're not really too far off, but it would be something that we would want to consider when troubleshooting. The view shown here is overhead, a bus bar, and we see that in this case, it's pretty consistent and it's pretty cool. If we were looking for a problem, this especially something with conductors that might be arcing or overheating, it would show up in a picture like this. Moving down from the ceiling to the wall, we have a shot here of a transformer, which we see, as we would expect, it runs warmer than the surrounding area. It puts out heat as part of its operation. We want to be aware of what that temperature is because we can catch something if it's overheating. This shot taken on the wall of control equipment highlights something worth bringing up. The VFD that we are pointing out on the right has a temperature of 104 in that area right there, so that's fairly warm. Is it warmer than it should be? Through our troubleshooting experience, we'll find out. We'll know that. Also, the other thing we can see from the regular picture is the light, possibly sunlight, is shining against the wall towards the left. So the elevated temperature that we see in the control boxes to the left may not be in the box, but may be a function of sunlight shining on the box and warming it up. This shot gives evidence of that. As we see from the regular photo, we can tell that the sun is shining outside and is heating up the exit door that we're looking at, as well as the overhead door next to that. If we are troubleshooting an electrical problem on an assembly machine like the one shown here, we can use thermal imaging to help pinpoint hot spots in the area. We can see on this photo the areas of the PLCs are warm, the power supplies above them, and then also some areas on the machine itself, which would be worth investigating. We see the image here of a robot where, as we would expect, the power supply is warmer than the other areas. The pendant is also shown, and sometimes we need to be concerned that we're picking up the light instead of the heat. We can see the comparison of the two photos here, where we would not necessarily suspect that there was a heat problem down below the robot, but we certainly can see it in the infrared photography. And when troubleshooting electrical problems, it would be worth checking out, as we see in this image, something that seems very warm when the surrounding area is not. Here's another example of a bit of an oddity. Why are the hot areas shown on this machine? It would be worth a little checking out to see if that would contribute to something we would want to investigate further. Let's go into the lab and experiment using infrared camera in electrical troubleshooting.